Hello friends, welcome back to the third session of DevOps. So in this session, we are going to cover the multiple critical and very important items related with the DevOps, which you can consider as a base for the DevOps, or you can also consider them as a benefits of the DevOps. Okay, but it's very important for you to understand all of the concepts, okay, because whenever we'll move with some advanced topics of the DevOps, okay, after the installation configurations of the multiple tools and then deployments, okay, then these kind of terms will come at multiple places, specifically in terms of the infrastructure setup. Okay, so this is a very important sessions, and all these topics will even not in the DevOps, it will help you in with respect to the some other stacks and softwares as well, because these are the core concepts that we utilize, okay, in building the infrastructure across the technologies. Okay, so let me quickly tell you what all are the topics that we are going to cover in this session. The first is redundancy, second is high availability, okay, and you can consider redundancy as a part of the high availability, okay, and the other terms that is related with the high availability are the load balancing, then you have a clustering, and then you have a failover, then scalability, and then maintainability. Okay, so these are the core concepts that you should understand from the infrastructure perspective, okay, as well as from the development or deployment perspective as well. Okay, because as soon as we'll move with the containerized solutions like the Docker, or with the orchestration solution like Kubernetes, okay, then all these terms will come at the multiple places. Okay, so you should have a complete understanding of all these topics. Now first, what is high availability? It is very clear from the name as well, high and then availability. So whatever the solution that you have, you should have a high availability of that particular solution. Okay, let us take that you have a small shop of the printing, okay, and you have a printer which you use to print the papers for your customers. If suppose that in any time this particular printer get crash, it is not working due to any reasons, then it is going to impact your business, right? Because customer will come to your shop and your printer is not working, it is directly a loss for your business, right? So what is the alternate for that to avoid this kind of a loss? You can have a alternate printer in place that can be standby, okay, or you may utilize both. Sometime you are using the first printer for printing, sometime you are using the second printer for printing, right? So that if one of your printer get crash, your business will not impact, you can do the printing from the second printer till your first printer get repaired, right? So if you have a single printer in your shop, this will not consider as a high availability. But when you have a redundant solution, so redundancy means more than one solution. So if we have a two printers, that means we have a redundancy here, that means we have a one more printer. So if any of the printer get crash, your business is not going to impact it, right? So this is called the high availability. You should have a alternate solution in place if one of the solution is going to be failed due to any reasons, right? And the multiple components are referred as redundancy, right? So this is the concept of high availability and then the redundancy. Now inside the high availability, we have a multiple other concept like load balancing, clustering, failover, scalability, maintainability, and those all are related to each other, right? So now if I talk about generally in how we do the setup in our production or live environments, okay, you know about that we have a multiple servers are in place, not a single servers, right? It could be virtual machine, it could be a physical servers where we have our multiple softwares are running, correct? Now why we have this kind of a redundancy of multiple servers? This is for the high availability. First, our solution should be highly available, right? Now other reason is the load, right? We have the multiple systems in place, and how we decide that how many systems we need or how many servers we need? Here we have a six servers, right? So how we decide if we need only 2 servers, or we may need only 6 servers, or maybe we need 20, 40, 50, or 100 servers for the virtual machines? It completely depends on the load. What kind of a load that is getting generated in your applications, right? Now, depend on your applications. You may have a web applications like an e-commerce web application. Okay, for example, Amazon, Netflix, etc. Okay, where you have a large number of user base, large number of user base. So that means there are uncountable number of connecting to your website in a day at a particular moment. So that means you have a very high load in your system. So if you have very high load in your system, then 1, 2 servers will not be sufficient. So you have to scale your system, okay, with the multiple servers, correct? And each server is going to have the same application. If it is suppose that you are running an Amazon e-commerce website, then you definitely want to go, or you want to install the same set of website on each and every server. You don't want that some of the users are getting some different website interface and some of the users are getting different website or different interface, right? So that means similar set of services we deploy across each and every server that we use for the load and then balancing, right? So now if we have a such kind of a load, and we know that we need at least 6 servers in place for our applications, right? So if you have 6 servers, now you definitely want to balance the load between the different servers, correct? You don't want any of the particular server to be overloaded, or on any of the couple of servers to be overloaded. You want to load the balance between each and every server. For example, if suppose that at a time 6 requests came from the internet for your website, or you can say 6 servers are using your website, okay, and they hit from the browser, from the internet, the first request will go to your first server, second will go to second server, third will go to third server, fourth will go to fourth server, similarly fifth and sixth will go to the subsequent server, right? So this is the definition of a load and then load balancing, correct? Now other concept is clustering. So when we have this kind of a scenario where we deploy same set of applications across all the servers, okay, we group them in a cluster. Okay, so here we have the concept of cluster. So this cluster concept you will see in the hardware as well as in the software as well. Specifically, when we talk about software, if you go with the application servers like the Tomcat, which is a lightweight application server, and then if you go for the WebLogic server, JBoss, WebSphere, okay, there you will see a concept of cluster where we create the multiple servers and then we group them in the same cluster. Okay, so that means in a cluster, each and every server is going to host the same set of applications. And now when we do the clustering of the same set of services, then we get a benefit, certain benefits like the failover. Now what is failover? For example, when a user access any of the website, then user session is connected to the server 1 here, right? Now suppose that this user is connected to your e-commerce website, and then he or she has spent a lot of time by searching for the multiple items in the e-commerce website, and then he or she added the multiple items in the shopping cart, okay, and in between when that particular user was connected to server 1, it get crash. Now what will happen to the user? Do you think that user again will going to be redirect to your website default front page? No, right? Because that would be a bad experience for the end user, especially if he or she has spent a lot of time for searching the different multiple products, and after adding the in the shopping cart, if again you are redirecting that particular user to the front page just because the backend server crashed. So this is a very frustrating situation for the customer side. You definitely don't want this kind of a situation. So for that we configure the failover. We have a feature called failover in the cluster. So if this kind of a situation arises where any of the backend server where the user is connected, it get crash, the session is automatically failover to the other running server in your cluster. Okay, so by this way we can avoid There are such kind of a scenarios which can have a bad impact on the end users. So this is called the failover, right? And then the other concept is scalability and maintainability. Let me explain you in the different notepad. Okay, there is some problem. Okay. Okay. So now what is scalability? Right? So suppose what we have discussed, suppose we have a 6 servers, 1, 2, 3, 4, 5, and 6. We have 6 servers today with us in our production environment. Okay, which we have configured based on our current user base, maybe by adding certain kind of a contingency, like if we are expecting 20,000 user today, we have added a 20% of contingency. That means somewhere around 4,000, and we have scaled our system today for the 24,000 of users. Right now, tomorrow your business is growing, and after some time, maybe couple of months or a year of a time, your user base has been increased. Earlier, suppose that your user base was 20,000, and now it is 30,000. So in that case, you need to scale your infrastructure as well, correct? So now, how soon you can scale your infrastructure? That means if you have a 6 server today, now today, tomorrow, you need to add 2 more servers. So are you going to build these 2 servers from the scratch? That means this is a new virtual machine that you have created. After that, you are going to install your all the softwares, whatever running in your current production environment. Then you need to going for the configuration or integrations, whatever you have in the current production. Then you are going to have to solve the different kind of dependencies that you have in your applications, right? And once everything is built, then you are going to plug in into your existing architecture. If it is the case, then consider how much time it is going to take. You have 2 servers, and practically it could be more than 2. It could be n number of servers. Now if you are going with the same exercises to install the software and then configuration, integration, resolve the dependencies, and then you are going to plug in the existing architecture, then it is a very time taking activity, right? That means your scalability is not feasible in that case. And also one of the benefit of the cloud is you can scale up or scale down your systems according to your requirement to save your cost. That means suppose that in 24 hours of a day, you have a load in the system which is minimum for 20 hours. Only for 4 hours it is the peak load in your system, right? So for rest of the 20 hours, you may need only 6 servers in your system, and for this 4 hours of peak hours, you may need 10 number of servers, right? So you can scale your system to 10 only for during these 4 hours, and then for rest of the 20 hours you can again scale down your system for only 6 servers. This is one of the benefit. So if this is one of the benefit, that means you can easily scale up or scale down your systems in your current production environment. Okay, then definitely you need a very short time for such kind of a scalability. Either you are going to up or you are going to down the number of servers in your architecture, correct? So that definitely, if this is the benefit in the DevOps and the cloud, okay, then this approach is not feasible, right? Because this approach is going to take a lot of time. So this approach definitely will not be there. So we need a certain solution for that one, and then we will discuss on that in detail in the next subsequent sessions. But what we are talking about here is scalability. So that means scalability in the sense how soon you can scale up your system and how soon you can scale down your system. In simple words, how soon you can add multiple other servers in your system based on your user base, and how soon you can reduce that one. This is called the scalability. Okay, and apart from the scalability, the other concept is maintainability. That means how easy to maintain your system. So if I'm saying that you need to add two more servers in your system, and again you need everything to be installed and configured from scratch, your maintainability is not good. If I'm saying you to deploy the application in your production, and if you're saying that I have 6 servers and I need a lot of time for the deployment because I need to log into each and every server and then I have to do the deployment, or maybe you are doing the deployment from some centralized location, okay, but you need time because there are 6 servers in the backend and your application going to take a time for the deployment. Again, you are not have a good maintainability. If you are saying that you may have a downtime for your application, then you have not a good maintainability solution in place. Okay, so maintainability means the impact on the production is very minimum, bare minimum, or almost zero. Even you are going for the maintenance of your application, maintenance of your hardware, deployment of the new applications, undeployment of the new applications, any kind of a configurations, your availability of the application should not be impacted. Okay, so this is called the high maintainability. How easy is the maintainability or the maintenance of your system, specifically in the operations and maintenance phase after your production goes live in the production environments, right? So now let me give you a quick recap again what we have discussed so far, because we have discussed the multiple important topics here. Okay, and I tried my best to simplify or explain in the simple way. So first we have explained about the redundancy. That means multiple systems. So redundancy can be for the software and it can be for the hardware, right? Because you need the multiple virtual machines or servers for the redundancy, and each and every machine you will have the same set of multiple softwares, right? Then you means you have multiple softwares and multiple hardwares, and this is called the redundancy, and this is one of the feature of the high availability, correct? Then you have a load balancing. So if we have a multiple servers are in place to cater the demand of the load, so you need to balance the request properly between all the servers. This is called the load balancing, right? And now we have the failover. So as I said, if suppose that some of the client is connected to in the backend server 1, and after 20 minutes when the user is still connected to that particular server, if that server get crash, the user should not face any kind of a error on the screen. Okay, your session should be automatically transferred to some of the other healthy server. This is called the failover. Scalability, how soon you can scale your system. Tomorrow you need 2 more server in your cluster to be added, or maybe 4, or maybe more than 4. It take hardly couple of minutes or a seconds of a time to scale up or scale down your system, which is called the scalability. How scalable is your system? Maintainability is when your system is in live production environment, how easy to maintain your system, how easy to deploy the new applications, how easy to undeploy the new applications, how easy to maintain the 24/7 availability of your applications, right? So all these are part of your maintainability. So these are the core concepts of your each and every stack, not a specific DevOps. You should understand, because when we are going to discuss about the Docker, Jenkins, and your Kubernetes and multiple other tools, okay, so there are all these terms will come at the multiple places, specifically when we are going to build our infrastructure for the applications. Thank you.